Welcome to Unacademy. Let us crack GATE and ESE ME. This is Umamaheswar Rao. This batch is super talent batch for engineering sciences. Complete maths will be covered by myself, Umamaheswar Rao, and technical subjects by JS Gill. Detailed coverage of GATE engineering sciences syllabus and extra practice sheets, handwritten notes. Tests are curated by JS Gill and myself. I am K. Umamaheswar Rao, educator at Unacademy. I have 20 plus years of teaching experience. I have guided more than 1 lakh students. Unacademy price hike is coming soon. Right now 20% off on all subscriptions. Get 20% off on all subscriptions. Use code KUR75. The offer is valid till 31st July. Padho, Kelo, Crack Karo, land with top educators in the month of July 1st to 30th. Concept based learning for each subject. Take a quiz and check your preparation. Top the leaderboard and get featured on YouTube channel. Get printed notes for your GATE preparation available for existing plus and iconic subscribers. Available for existing plus and iconic subscribers. Mechanical engineering, civil engineering, electrical engineering, electronics and communication engineering, computer science and information technology. Abhishek, definitely I will cover LU factorization as well as diagonalization problems. Don't worry. Entire syllabus of engineering sciences will be covered in this batch. Attention Unacademy GATE and ESE aspirants, get iconic subscription at just additional 555 rupees per month. Benefits of 1:1 live mentorship program with Unacademy GATE and ESE iconic subscriptions. 1 free 30 minutes mentor introductory session. Schedule session as per your convenience. Progress report available to the mentor for tracking learner activity, exam and preparation guidance. The features of Unacademy: top educators, doubt clearing sessions, special doubt clearing sessions, study notes, test series available for both iconic subscriptions and plus subscriptions. Physical notes, 1:1 live mentorship program, strategy and study program, live audio interactions during open house available only for iconic subscribers. You can avail loan and no cost EMI for GATE and ESE iconic subscription. Approval in 2 hours. Unacademy is announcing Lakshya batch for GATE 2023. Batch commences from July 21st. Unacademy is announcing Pragati batch for GATE 2024. Batch commences from July 21st. Use code KUR75. Either for plus subscription or iconic subscription, use code KUR75. Yesterday I have covered limits, continuity and differentiability. Concept of limit, continuity and differentiability. Today I would like to discuss problems related to limit, continuity and differentiability. Now first problem, limit x tends to infinite e power 1 by 5x minus 1 into 5x plus x by 5 sine 1 by x. Limit x tends to infinity is nothing but 1 by x tends to 0. E power 1 by 5x minus 1 multiplied with 5x plus limit 1 by x tends to 0. E power 1 by 5x minus 1 multiplied with x by 5 into sine 1 by x. Limit 1 by x tends to 0. E power 1 by 5x minus 1 by 5x plus limit 1 by x tends to 0. E power 1 by 5x minus 1 into 1 by 5 sine 1 by x by 1 by x. E power t minus 1 by t tends to 0 is 1. 1 plus 0. Final answer is 1. So the value of limit is 1. E power 1 by 5x minus 1 by 5x. 1 by x tends to 0 is e power t minus 1 by t tends to 0 is 1. So first limit becomes 1, second limit becomes 0, e power 0, that is 1, 1 minus 1 is 0. So 1 plus 0 is 1. So final answer is 1. The values of a and b for which f of x equal to 2x plus 1 when x less than or equal to 1, which is ax square plus b if 1 less than x less than 3, 5x plus 2a when x greater than or equal to 3. If the function is continuous everywhere, then what are the values of a and b? If the function is continuous everywhere, the function is continuous at 1 as well as at 3. F of x is 2x plus 1 if x less than or equal to 1. Ax square plus b if 1 less than x less than 3. 5x plus 2a if x greater than or equal to 3. Observe here, when x is tending to 1, 2 plus 1, 3. When x is tending to 1, a plus b. Left limit is 3, right limit is a plus b. Now, the function is continuous at 3. Therefore, when x is tending to 3 from left, 9a plus b. That is left limit. Right limit at 3, 15 plus 2a. That is 7a plus b is 15. Called it equation 2. A plus b equal to 3 from 1 and 2. A plus b equal to 3, 7a plus b equal to 15. Subtract, minus, 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 plus minus cancel, minus 6a equal to minus 12, therefore a is equal to 2, therefore b equal to 1. A is 2 and B is 1 is the correct answer. A is 2, B is 1. The values of A and B for which limit x tends to 0, A sin square x plus B log cos x by x power 4 equal to 1 by 2. limit x tends to 0, a sin square x plus b log cos x by x power 4 equal to 1 by 2. b log cos x by x power 4 equal to 1 by 2. When x is tending to 0, numerator is tending to 0, denominator is tending to 0. That's why apply L'Hospital rule. Limit x tends to 0. Differentiation of denominator is 4x cube. Differentiation of numerator is a into 2 sin x. Differentiation of sin x is cos x plus b into 1 by cos x. Differentiation of cos x is minus sin x equal to 1 by 2. Limit x tends to 0. 4x cube is denominator. Numerator is a into sin 2x minus b tan x equal to 1 by 2. When x is tending to 0, numerator is tending to 0, denominator is tending to 0. Now, again apply L'Hospital rule, limit x tends to 0. Differentiation of numerator is 2a cos 2x. Differentiation of b tan x is b secant square x by differentiation of 4x cube is 12x square equal to 1 by 2. When x is tending to 0, numerator is 2a minus b. 2a minus b by 0, something by 0 is finite. That is possible only when 2a minus b equal to 0. Called it equation 1. Now, again it is 0 by 0 form. Apply L'Hospital rule. When 2a equal to b, then 0 by 0 form will come. So, denominator is 24x. Numerator is minus 4a sin 2x minus b into 2 secant x into secant x tan x equal to 1 by 2. It is 0 by 0 form. Apply L'Hospital rule. Limit x tends to 0. Denominator is 24x. Numerator is minus 4a sin 2x. 2b secant square x into tan x equal to 1 by 2. When x is tending to 0, numerator is tending to 0, denominator is also tending to 0. Differentiate. Limit x tends to 0. Differentiation of denominator is 24. Differentiation of numerator is minus 8a cos 2x. Minus 2b secant square x into tan x. Differentiation of tan x is secant square x plus tan x into 2 secant x into again secant x tan x equal to 1 by 2. When x is tending to 0, minus 8a minus 2b by 24 equal to 1 by 2. Minus 8a minus 2b equal to 12 minus 4a minus b equal to 6. Called it 2. From 1 and 2. From 1 and 2. 2a is equal to b. Therefore, 4a equal to 2b. Minus 3b equal to 6. So, b equal to minus 2. A equal to minus 1. B equal to minus 2. So, the value of a and b are minus 1, minus 2. First option is correct. Next one. Limit x tends to 0, x into e power x minus 1 plus 2 into cos x minus 1 by x of 1 minus cos x. When x is tending to 0, numerator is tending to 0, denominator is also tending to 0. Apply L'Hospital rule. Limit x tends to 0. Differentiation of denominator, x into differentiation of minus cos x is sin x plus 1 minus cos x into 1. In the numerator, x into differentiation of e power x minus 1 is e power x. E power x minus 1 into differentiation of x is 1. 2 into differentiation of cos x is minus sin x. When x is tending to 0, numerator is tending to 0, denominator is also tending to 0. Apply L'Hospital rule. Limit x tends to 0. Differentiation of denominator, x into cos x plus sin x. Differentiation of 1 minus cos x is sin x. In the numerator, x into e power x plus differentiation of e power x minus 1 is e power x. Differentiation of minus sin x is minus cos x. Again, numerator is 2 minus 2, 0. Denominator is also 0. 0 by 0 form. Apply L'Hospital rule. Limit x tends to 0. Differentiation of denominator is cos x into differentiation of x is 1. Differentiation of cos x is minus sin x. Differentiation of sin x is cos x. Differentiation of sin x is cos x. Now, differentiation of x e power x is x into e power x plus e power x. Differentiation of e power x is e power x. Differentiation of e power x is e power x. Differentiation of minus 2 cos x is 2 sin x. When x is tending to 0, numerator is 1 plus 1 plus 1 by denominator 1 plus 1 plus 1. 3 by 3. Final result is 1. The value of limit is 1. Abhishek, how I have written first equation means something by 0 generally not defined, but they have given 1 by 2. Something by 0 equal to 1 by 2 is possible only when if it is 0 by 0 form. 0 by 0 form is possible only when 2a minus b equal to 0. Based on that logic, I have written equation 1. I hope you understand. Next problem. Let L is limit x tends to pi by 2 sin square 2x by x minus pi by 2 whole square. When x is tending to pi by 2, numerator is tending to 0, denominator is also tending to 0. That's why you have to apply L'Hospital rule. Numerator 2 sin 2x differentiation of sin square 2x is 2 sin 2x into differentiation of sin 2x is 2 cos 2x. Differentiation of x minus pi by 2 whole square is 2 into x minus pi by 2 into 1. Now 2 cancel. Numerator is limit x tends to pi by 2 sin 4x by x minus pi by 2. When x is tending to pi by 2, numerator is tending to 0, denominator is also tending to 0. 0 by 0 form. Now limit x tends to pi by 2. Differentiation of denominator is 1. Differentiation of numerator is 4 cos 4x. When x is tending to pi by 2, 4 cos 2 pi. So the limit is 4. The limit is 4. Pranavi, it will take minimum 4 months. So July, August, September, maximum September or by October 10th. Okay? Because daily 1 hour na, that's why. Let f of x equal to sin x by x not equal to 0, which is 1 when x equal to 0, then f is not continuous at x equal to 0, f is continuous at x equal to 0 but not differentiable at x equal to 0, f is differentiable at x equal to 0 and f dash 0 is 0, f is differentiable at x equal to 0 and f dash 0 is 1. So here the function is sin x by x when x not equal to 0, which is 1 when x equal to 0. I am calculating f dash of 0. The derivative of the function at x equal to 0. X tends to 0. F of x minus f of 0 by x minus 0. Limit x tends to 0. F of x is sin x by x. F of 0 is 1 by x minus 0. Take LCM. Limit x tends to 0. Denominator is x square sin x minus x. When x is tending to 0, numerator is tending to 0, denominator is tending to 0. 0 by 0 form. Apply L'Hospital rule. Limit x tends to 0. Differentiation of sin x is cos x. Differentiation of x is 1 by differentiation of x square is 2x. When x is tending to 0, again numerator is tending to 0, denominator is also tending to 0. Again 0 by 0 form. Apply L'Hospital rule. Differentiation of denominator is 2. Differentiation of numerator is minus sin x. When x is tending to 0, limit is 0. Therefore, f dash of 0 is 0. F dash 0 is finite. Therefore, it is differentiable at x equal to 0 and f dash 0 value is 0. Therefore, third option is correct. The function is differentiable at x equal to 0 and f dash 0 is 0. Next one. What should be the value of lambda such that the function defined below is continuous at x equal to pi by 2? The function defined below is continuous at x equal to pi by 2. The function defined below is continuous at x equal to pi by 2. A function f of x is said to be continuous at pi by 2. Limit x tends to pi by 2. F of x equal to f of pi by 2. Limit x tends to pi by 2. What is f of x? Lambda cos x by pi by 2 minus x. Functional value at pi by 2 is 1. Now, limit is 0 by 0 form. Limit is 0 by 0 form. Apply L'Hospital rule. Limit x tends to pi by 2. Differentiation of pi by 2 minus x is minus 1. Differentiation of lambda cos x is lambda into minus sin x equal to 1. So now, when x is tending to pi by 2, lambda into minus sin pi by 2 by minus 1. So sin pi by 2 is 1. So minus 1 cancel. Therefore, lambda is equal to 1. So the value of lambda is equal to 1 is the correct answer. The value of lambda is equal to 1 is the correct answer. Understood? Next one. F of x is x power a into sin 1 by x is differentiable at x equal to 0. Is differentiable at x equal to 0 for all values of a in the interval. See, the function is differentiable at x equal to 0 means f dash 0 exists. X power a into sin 1 by x minus 0 by x minus 0. Limit x tends to 0. X power a minus 1 sin 1 by x. Here the limit exists only when a minus 1 is greater than 0. Limit exists when a minus 1 greater than 0. Therefore, a must be greater than 1. The value of a should belongs to the interval 1 to infinite. The derivative of the function f dash x is finite. Only when a belongs to the interval 1 comma infinite, a must be greater than 1. So correct answer is 1 to infinite. Correct answer is 1 to infinite. Which of the following is continuous at x equal to 3? When x is 3, at x equal to 3, functional value is 2, right hand limit is also 2 because x minus 1, so 3 minus 1, 3 minus 1 is 2. Left hand limit 3 plus 3 by 2, x plus 3 by 2, that is 3 plus 3 by 2, that is 3. No, 2. That is 3 plus 3 by 3. That is 2. Left limit is 2, right limit is 2. Functional value at 3 is 2. Therefore, the function is continuous at x equal to 3. The function is continuous at x equal to 3. Understood? Next. A function f of x is defined as f of x equal to e power x when x less than 1, log x plus ax square plus bx when x greater than or equal to 1. Which of the following is true? Now, f dash x is differentiation of e power x is e power x, x less than 1, differentiation of log x is 1 by x, 2ax plus b when x greater than or equal to 1. Now, left hand limit when x is tending to 1 e, right hand limit log 1 0 a plus b. So from continuity part we got one equation, a plus b equal to e, left hand derivative e, right hand derivative 1 plus 2a plus b. That is, when the function is differentiable, left hand derivative equal to right hand derivative. From this we can write one equation, 2a plus b equal to e minus 1, 2a plus b plus 1 equal to e, therefore 2a plus b equal to e minus 1. Called it equation 2. From 1 and 2, a plus b is e, 2a plus b is e minus 1. From this we can write b cancel, a minus 2a is minus a equal to plus 1, therefore a equal to minus 1. If a is minus 1, b is e plus 1. A is minus 1, b is e plus 1. Therefore, for unique values of a and b, the function is differentiable at x equal to 1. Unique values of a and b, the function is differentiable at x equal to 1. Consider Consider the function f of x equal to mod x whole cube. The function f of x at x equal to 0 is here mod x whole cube. Mod x is minus x when x less than 0. Mod x is plus x when x greater than or equal to 0. Now f of x is mod x cube mod x whole cube, that is nothing but minus x cube when x less than 0 plus x cube when x greater than 0. Now when you calculate left hand limit 0, right hand limit 0, functional value at 0 is also 0. Therefore f of x is continuous at x equal to 0. Now f dash x is differentiation of minus x cube is minus 3x square. Differentiation of x cube is plus 3x square when x greater than or equal to 0. Left hand derivative, when x is tending to 0, left hand derivative is 0. Right hand derivative 0. Left hand derivative equal to right hand derivative. Therefore f dash 0 exists finitely. Therefore the function is differentiable first time. Next, f double dash x minus 6x when x less than 0 plus 6x when x greater than 0. Now left hand derivative 0, right hand derivative 0. Therefore you can conclude that f double dash 0 exists. F double dash 0 exists finitely. Second time differentiable. Now third derivative f triple dash x minus 6 when x less than 0 plus 6 when x greater than 0. Left hand derivative not equal to right hand derivative. Therefore f triple dash 0 does not exist. F triple dash 0 does not exist. Therefore we can conclude that the function is differentiable 2 times but not thrice. Differentiable 2 times but not thrice. That is the correct answer. The function f of x equal to mod x when x less than 0, mod x when x less than 0, x when x greater than or equal to 0. Mod x means minus x plus x when x greater than 0. Calculate f dash x. One minute. Differentiation of f of x. Now graph of f of x. Graph of dy by dx. This is y equal to x, y equal to minus x, 0, 1, minus 1, like that. That is graph of f of x. Now, graph of dy by dx is x axis, y axis, one, minus 1, 0, if you look at the graph, f of x is continuous, but dy by dx is not continuous. Dy by dx is discontinuous at 0. Understood? Therefore, f of x is continuous. I mean y is continuous, but dy by dx is discontinuous at x equal to 0 is the correct answer, because the graph of dy by dx is discontinuous at 0. Next one, the function y is equal to mod x plus 1 in the interval minus 2 comma 0. Mod x plus 1 modulus of x plus 1 in the interval minus 2 comma 0. That is x axis, y axis. In the interval minus 2 comma 0, in the interval minus 2 comma 0, mod x plus 1 is continuous but not differentiable at minus 1. Mod x plus 1 is not derivable at minus 1. That's why it is continuous on the interval but not derivable at all points. Mod x plus 1 is not derivable at x equal to minus 1. That's why in the options, the function is continuous on the interval but not differentiable at all the points. Because at some points, It is not derivable. What is that point? -1. Understood? Thank you.